Hello Laurel, it's Mr. Green here. I'm going to be doing your next few maths lessons. So I've looked at what you've been doing with Mrs. Sperry and you've been working on multiplication. You've been doing mental multiplication, so timesing things in your head. Now by the end of next year, by the end of year 4, you'll be doing your times tables tests and you'll have to know all of your times tables up to 12 times 12. So I hope that you've started learning lots of them already and you should know a fair few of your times tables. And these are brilliant and it's going to be very, very useful for this. But sometimes numbers get bigger than your times tables can do. Things get bigger than 12 of something. So we're going to have to look at another method, a written down method that you can use to solve bigger multiplication problems. We're going to look at the grid method. And we're going to do that using Jaffa cakes. These are really good. These are little chocolate covered biscuit cake things. And they come in packs of 10, which is brilliant because lots of things in maths work in groups of 10. So let's start by recapping multiplication. So this is an array. My array is made up of Jaffa cakes. So 3 times 5, this means 3 people each going to have 5 cakes. How many cakes have they got altogether? Here's my first person. Here's my second person. They can have nice hair. And here's my third person. They can have spiky hair. And they've each got 5 cakes. How many cakes have I got altogether? I've got 5, 10, 15. 15, I can count them one at a time if I want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is saying I have got 3 groups of 5. There's one group of 5, 2 groups of 5, 3 groups of 5. Now, if I clear that pen marking. Now, the nice thing about an array is they spin around. So, let me come out of this for a second. But 3 groups of 5, when turned on its side like that, suddenly I've now got this. I don't have 3 groups of 5 anymore. I've got 5 groups of 3, but I've got the same number of Jaffa cakes. I didn't eat any. None appeared and none disappeared. They just turned round. And they're round, so it doesn't matter. A Jaffa cake turned round is still a Jaffa cake. No more, no less. 3 times 5 is 15, but 5 times 3 is still 15. It's exactly the same array, I just turned it round. This is all stuff which I'm sure you know. Now, the next thing is something I'm pretty sure you did on your last lesson. So, these are Jaffa cakes. That's 1 Jaffa cake. This is 6 Jaffa cakes. And I could write 6 in the ones column because I have got 1 Jaffa cake 6 times. However, sometimes you have more Jaffa cakes. These have got 10 in each packet. 10 in there, 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 and 10 in there. I can see 6 things, but I haven't got 6 ones. I can't put 6 in my ones column. Well, each of these has got 10 things in it, so I can write 6 in my tens column. 6 tens. 10, 20, 30, 40, 50, 60. 6 in my tens column, but I can't leave it like this. I've got to put something to show that this ones column isn't, well, it's empty. And I write that. That shows me it's 60. So this is 6 cakes, but this is 60 cakes. The same digit 6 because they're still 6 things, but it's moved one place to the left, and in the space that it left, I've put a placeholder, a 0 that just holds that place, tells me that that place is there, so I don't think it's something else. Now this is an important thing to know. 60 is 10 times bigger than 6, but it still kind of looks like 6 things. This means I can do bigger arrays. Here, for example, I have 3 people but they've all got 50 cakes each. Here's my first person, here's my second person, here's my third person. They've now got 10, 20, 30, 40, 50 cakes each. But I haven't got to write out all 50. I can just see that there's 10, there's 20, there's 30, there's 40, there's 50. So I don't write 5 in my ones column, I write 5 in my tens column. Now I've got 3 lots of these. Well, I can do this just like the 3 times 5 times table. 3 times 5 is 15. But this is 10 times bigger. Every box isn't 1, it's 10. I need to make 15 10 times bigger. Now I can write 15. To make it 10 times bigger, we said that everything needs to move up 1. Everything needs to go left 1. And if everything goes left 1, I end up with this. And again, I've got a space, I've got a gap, something needs to go in that gap. I can't leave it open. I put a placeholder, something to hold that place. That's a 0. So 3 times 50 is 150. So 3 times 5 is 15. 3 times 50 is 150. It looks the same, but because this is 10 times bigger, this has to be 10 times bigger. Because the 50 got moved left and a 0 was put in, the 15 needs to be moved left and a 0 is put in. And just like my array before, come on, close. Just like my array before, I can spin it. At least I can try. Not quite sure why a packet of Jaffa Cakes has turned into a blue box. There we go, it's come back again. And I can turn it round, and I've now got 5 lots of 30 Jaffa Cakes. So 3 times 50 and 5 times 30 are the same thing, I've just turned the boxes round. They're the same boxes, they still taste the same inside. So my answer will be the same. 3 times 50, is the same as 3 times 5, which is 15, but 10 times bigger. So 50 times 3, which is the same thing but back to front, all I've done is spinned my array around, is still going to be 150. Now this is important because of this. I can take a number that I don't know a times table for, like 32, and I can split it up. And I can say that 32 is made of 30 and 2. I can times both of these bits by 5. Now 2 times 5 is easy, that's 10. 30 times 5, it's the same as 3 times 5, which is 15, but 10 times bigger. And then I can put these bits back together again, and I can say 150 plus 10 is 160. So 32 times 5 is 160. But this is quite a messy way of laying it out. We want something a bit neater than that, so we're going to use a grid. Now, if you've got a printer and you're doing this, you can print out some grids I'll give you, some blank grids. You can print them out and you can do the work in that. If you can't, it's not that hard to draw in your book. You've just got to draw some lines going down and a line going across. Those are actually the only bits that you need. You can do the box around the outside, but those are the only bits you need. So, I've got a grid. My grid's got 6 boxes in it. The first box gets the times symbol in it. I don't need it for anything else, so I'll just put the times symbol in it to remind me that I am timesing. The smallest number goes in here. Now sometimes the smallest number will be second, sometimes the smallest number will be first, but as we just saw, it doesn't really matter. We're going to put the smallest number in here, 5, and we're going to need to know our 5 times tables. And then the other number is going to be split between these 2 boxes. This one is my tens, and this is my ones. So what's 32 made of? Well, it's made of 30, so 3 tens, and 2. This is 3 boxes of 10 Jaffa Cakes, and 2 Jaffa cakes. This is how I set out my grid method. I've now got 30 and 2 to times by 5. Now, what's 2 times 5? 2 times 5 is 10, and that goes in here. 30 times 5 is like 15, is like 15, but 10 times bigger, so everything moves up one. And then we add that placeholder. And now I need to add these two things up. I could use a column addition, or I could just do it in my head. 0, 6, 1, 160. Okay, we're going to do a few more as a practice, and then you're going to have a go at doing some on your own. Watch the method. I want you to understand it, but I also want you to see what I do. There's only a few stages to this. So, stage number 1, find the smallest number and write it in here. The smallest number in this question is 4. Find the biggest number and partition it into tens and ones. 32 is made of 30 and 2. Now, this box here is this number times the number over there. 2 times 4, that's his 8. And then this box here is this number times this number. 30 times 4 sounds really hard, but you do 3 times 4. 3 times 4 is 12. 10 times bigger than 12 is 120. And now I add them up. 120 add 8 equals 128. If you've not seen written methods before for adding, you can just do that adding in your head. So 120 add 8. I need to go up here and write it next to my question. There's no point in having a lovely written method if you never actually write the answer in. So 32 times 4 is 128. Let's try another one. 25 times 3. So the smallest number goes in this box here, 3. The biggest number gets partitioned. 25 is 20 and 5. 20 and 5. I'm going to start in the furthest away box. That's got a 3 next to it and a 5 above it. 3 times 5 is 15. Easy times tables. Then I'm going to do the next box. This has got a 3 next to it and a 20 above it. 3 times 20. 3 times 20 is like 3 times 2, which is 6, but 10 times bigger, which makes it 60. I now need to do 60 add 15, which is 75. Okay, these are your examples. Now, I'll give you a copy of this page, but I want you to do the work either in your book or on the sheet that I give you with some grids on for you that you can print out. It gives you an example at the top of the page just to remind you what we're doing. So they're doing 3 times 34. They put the 3 in this box here. They split the 34 into 30 and 4, put the 30 there and the 4 there. Then they've done 3 times 4 is 12, and then 3 times 30. 3 times 30 is the same as 3 times 3, which is 9, but then 10 times bigger, 90. And then they've added 90 and 12 together, which gives them 102. So the next one, they've drawn the grid for you. They've already done the 5 goes in here. They've already split the 23 into 20 and 3. You've got to do 5 times 3 and put it in there. 5 times 20, which is the same as 5 times 2, but 10 times bigger, and put it in there, and then add the 2 bits together. After that, you've got to do them yourself. There are 11 questions there. And then at the end, there's this quite tricky question here. This is something 5 times something equals 175. And there are 2 different multiplications you could do that have a 5 in the ones column. So I'd like everybody to have a go at this. You can have a go at this if you want to. We'll call this level 2. And we'll call this level 1. So it'd be nice if you all had a go at the first lot. Have a go at the second bit if you want to try and push yourself. Notice some of these, they've written the multiplication the other way around. Doesn't make any difference. You've still got a smaller number that goes in the box underneath the times, and you've still got a bigger number which you need to partition into 2 bits. Okay? Any problems, just send a message. Mrs. Sperry will still be marking this, Mrs. Sperry will still be looking at this. Mrs. Sperry and Mrs. Osborne are still there to help and answer your questions and all those things like they normally would. I'm just delivering the lesson for them. Okay? So any problems, drop them a message. Or possibly Mrs. Lambert if you're in her group. Okay, have fun.